Hi everyone, my name is Sage Govender, and I'm a master's student with the Minerals to Metals initiative at the University of Cape Town. Today you'll be hearing more about my research topic, which is titled Repurposing Mine Waste, a Mineral Sands Case Study. I hope you enjoy.
It is globally known that the mining industry produces the largest waste stream, where the commodity produced is far outweighed by the waste it generates. This is, however, continuously increasing due to mineral demand and advances in mining technology. But this comes with its own suite of problems. The conventional disposal and storage of solid mine waste takes permanent residence on land, which requires costly, long-term management and poses risks to the surrounding environment and communities. Prime examples include tailing dam failures, seepage from these facilities into water sources, and suspended dusts that can extend into perpetuity, thereby contributing to the unsustainability characteristic of a linear economy in mining. Additionally, this represents the loss of potentially useful or valuable material that can be reprocessed or repurposed on a case-by-case basis for socio-economic benefit. Mine waste valorization therefore also contributes towards the goal of the Global Tailings Management Standard by reducing the waste burden and lowering chances of long-term pollution. Globally, many applications have been explored for the various types of mine waste, which range from construction and industrial materials to landscaping. This displays the concept of a circular economy based on principles of industrial ecology, which just promotes the use of waste as a secondary resource and carries the potential to create downstream industries. These outputs of mine waste usage therefore have the potential to attain many of the Sustainable Development Goals. South Africa likewise faces this global waste problem and has explored some of the options for repurposing solid mine waste. Focus has been placed on our major coal and gold sectors. However, no or limited studies on the application of such approaches have been considered for our mineral sands sector. This small and often neglected sector ranks second in the world in terms of the production of titanium and zirconium from minerals like ilmenite, rutile, and zircon. The extraction of heavy minerals from mineral sands during open pit mining involves dredging or excavating the unconsolidated coastal sands. These deposits, however, only contain about 10% of total heavy minerals. This leaves at least 90% to be disposed of in waste storage facilities, which highlights the waste concern. The repurposing or reuse of mineral sands, therefore, becomes a very important issue to reduce this concern and the associated effects. Due to the lack of previous research addressing mineral sands waste valorization approaches, potential opportunities were investigated by reviewing existing approaches for solid mine waste. For the purposes of this project, tailing valorization opportunities were focused on. These included fine aggregates that can be used in construction materials such as wall mortars and renderings, methods of backfilling and co-disposal, which refills the mined out pits and is used to neutralize acidic wastes in some cases, brick making utilizing methods of clay firing, cementing, or newer methods of geopolymerization, ceramics for use as tiles, Foundry sand for molding casts, and fabricated soils for use in mine rehabilitation and crop growth. In reviewing these approaches, 3 prominent points stood out. Firstly, all these approaches used waste with a silica-rich base component in the form of quartz. Secondly, the deleterious metal content is important to understand due to their effects on production chemistry. And thirdly, particle sizes will have an effect on the product strength, so it is important to determine the size fractions of the waste. These points, however, are purely based on laboratory studies and lack in an interdisciplinary approach. With this in mind, my research was designed to investigate potential opportunities for repurposing mineral sands mine waste. not only based on consideration of its physicochemical properties, but will also try to holistically consider the implementation of the approaches in context. This will be achieved in 3 phases. Phase 1 will investigate the physicochemical characteristics of the mineral sands mine waste. Phase 2 will apply a decision support framework to aid the identification of potential opportunities for repurposing mineral sands mine waste, holistically and in context. And Phase 3 will demonstrate proof of concept for 1 or 2 of the most promising opportunities for repurposing mineral sands mine waste. In investigating the physicochemical properties in Phase 1, a variety of analytical techniques will be used. Particle size determination will be carried out using sieving and instruments for laser diffraction. The chemistry will be analyzed using inductively coupled plasma mass spectrometry and X-ray fluorescence. And lastly, the mineralogy will be determined using quantitative evaluation of minerals by scanning electron microscopy and X-ray diffraction with Rietveld refinement. Phase 2 considers technical, economic, environmental, and social aspects. This requires an in-depth, semi-quantitative study for each consideration. So, for example, the environmental considerations will include looking at each approach's ecological sustainability and processing, the quantity and hazard state of waste it generates, as well as quantifying the potential water and energy consumptions. These will be combined with the physicochemical properties in the application of an existing decision support framework, which will enable the selection of the most appropriate option or options from the waste valorization approaches reviewed in a local context. Phase 3 will demonstrate the proof of concept of the selected approach or approaches by experimentation once Phase 2 is completed. The product of this will fall under the 3rd technology readiness level, which concludes the research phase. Further development outside the scope of the study will proceed from level 4. The expected results from each phase will contribute the following. The physicochemical characterization in Phase 1 is crucial in determining the secondary usage of the waste. This will also contribute to the limited knowledge of variation within mineral sands mine waste. The application of a decision support framework in Phase 2 will introduce a holistic set of considerations involved in selecting approaches for mineral sands mine waste in context, which is also limited in waste valorization studies, but is slowly gaining traction. And lastly, Phase 3 will practically confirm theory. This sits at the lower end of the technology readiness levels, but will provide a base from which to further develop the approach or approaches. So, in a take-home message, this project will contribute to sustainable processing and closure, while addressing a number of the Sustainable Development Goals. Mine waste usage promotes responsible consumption. This strives to decrease the negative environmental impacts associated with mine waste storage, while simultaneously encouraging innovation and potential downstream industries. And ultimately, the knowledge procured in the study will add to the limited global research on mineral sands mine waste valorizations. Thank you.